So for this golfer problem, the golfer hits a tee shot with an angle of 25.68 degrees. 6.1 seconds later, it hits the ground 118 meters away from the tee. What is the maximum height that the ball reached? I've already written down our knowns. We know delta x. We know acceleration in y direction. We know the change in time. We know the angle, theta here. And that's it. That's all we know right now. And we want the maximum height the ball reached. So let's think first about what's going to happen here. If we do this, the ball's going to do this, and it's going to come back down to right there. So we want this distance. This is the delta y that we want. So our actual answer that we want is delta y. Alright, so what happens at the top of this flight, at the top of its trip? Well, if at its highest point, it stops doing what? It stops going up. Means that when it's at its highest point, it's neither going up nor going down. So that means that our velocity in the y direction is 0. Now we can call this the final velocity, or we can call this the final velocity, but we're worried about this displacement. So if we're looking for this displacement, the final, in quotation marks, velocity is 0 because we're at our highest point. Hey, so that gives us a known. If we know t and a and vfy, what can we figure out? Now you may be tempted to use kinematics to find vi and then find delta y going that way. But there's actually an easier way to find vi, and one that's going to give us a more approximately correct answer. If you notice, we've got delta x and we've got delta t. So we can say v bar x equals delta x over delta t. So we can find v bar x pretty easily. Delta x is 118, delta t is 6.1, so we know vx is going to be just that quotient, so 118 divided by 6.1. So we're going to get that vx is about 19.34. Okay, if vx is 19.34, we can find vi. Why? Because we know 25.68. So tangent of 25.68 equals opposite viy over vxi in this case, which is how much? .34. Alright, so just like looks like VIY is just going to be that product, 19.34 times tangent of 25.68. So it looks like VIY is actually 9.2994. Okay. So now we know VIY. And we know everything else, so we can pick really whatever formula we want. But let's do this one. Let's do delta y equals 1/2 vi plus vf delta t, and these are both y's. So 1/2 times 9.2994 times 6.1 equals 28.363. Let's go check it. we got it. Alright? Now, it may have been tempting to, like I said, solve for VI using one of the kinematics equations, using delta y, ay, and delta t. The problem there would be that you wouldn't necessarily get an answer that agreed with the other knowns in the question. You know, we had to make sure that the Vy agreed with the Vx. And so since they gave us everything we needed to find Vx, we needed to go that way to do this question. So this is a little bit weird. But this is the type of problem you're going to see where you figure out something in the x direction, transfer it to the y direction, and do that. Normally we just figure out time and trade it over. This time we actually had to find the x velocity and use trig to find the y velocity.